Welcome to homework.
So once again, we have a new problem. This time it's still on diffraction. We have a diffraction grating, and obviously it's going to have a couple of slits, and it so happens that think about these slits as being 400 lines, has 400 lines per millimeter, and we want to find out in terms of the visible spectrum. Obviously, if it's a grating, then there's a screen and there's light going through. There's light going through the visible spectrum. The visible spectrum is between 400 and 700 nanometers. That's the visible spectrum. And we want to find out, this is the information that's given. We want to find out the number of orders of the entire visible, I was going to say physical, but it should be visible spectrum. Entire visible spectrum. That's what we want to find out. And this includes the order m equals to 0. It includes the order m equals to 0. So we're going to jump into the next page to start the problem. We do know that for a single slit in the experiment, the diffraction grating has the equation d sine theta equals to m lambda, where d happens to be the slit width. Theta is the angle of diffraction. Obviously, if you go back, you get to see that the angle would be somewhere right there, theta. And then, of course, lambda is the wavelength. Lambda is the wavelength, and m is the order of the diffraction. And we want to find the number of orders for the visible spectrum. We know the visible spectrum lies between 400 nanometers and 700 nanometers. The number of lines in the grating is 400 lines per millimeters. We can transform that into meters. Pretty much we're saying, how many lines do we have in 1 meter? So 1 meter is 1,000 millimeters. So we're going to have 4.00 times 10 to the 5 lines per meter. The slit width, d, is the reciprocal of the number of lines. The slit width is the reciprocal of the number of lines in this instance, because we want to find, if we have 4 times 10 to the 5 lines, how many, what's the width of the slit in this case? So it ends up being 0.25 times 10 to the negative 5 meters. That's the width of the slit whenever you have 4 times 10 to the 5 lines. In the next page, we maximize the sine theta. So sine theta has a maximum of 1. If you think about graphing a sine graph, you see that the sine is 1 at max. If this is your y-axis and that's your x-axis, and this is your graph. And so if sine of theta is 1 and d sine theta equals to m lambda, so it follows that d times 1 equals to m lambda. Helps us to solve for m, which is the order, so d over lambda, and on the visible spectrum runs from 400 nanometers to 700 nanometers. So we're going to start with the 700 nanometers for lambda. And so m equals to d, which is 0.25 times 10 to the negative 5 meters over 700 nanometers. Change that to meters. 1 meter is 10 to the 9 nanometers. And so this gives us 3.57, which is approximately 3. So the order is m equals to 3 for the spectrum of 700 nanometers. And so if m equals to 0, we're going to have 3 orders above it and then 3 orders below it on both sides. Our next stop is when the lambda is 400 nanometers. We can transform that to meters. And so m, remember in the previous page, was d over lambda. That's the order. D still stays as 0.25 times 10 to the negative 5. Remember, d is the slit width when we have 4 times 10 to the 5 lines. And so for 400 nanometers, we change that to meters to solve for the orders, and m becomes equivalent to 6.25, which is approximately equal to 6. The reason why we choose 6, that's on the lower side. So for spectrum 400 nanometers on the visible spectrum, the order m is 6, and so the number of orders between 400 nanometers and 700 nanometers will be between m equals to 3 and m equals to 6. So m becomes equivalent to 6 minus 3. So our order between the visible spectrum is m equals to 3. So once again, we had the visible spectrum in this case. Between 400 and 700, we had to find the number of lines, given that n is 400 lines per millimeter. So we changed that to how many lines per meter, 4 times 10 to the 5. And also we had to get the slit width, which is 0.25 times 10 to the negative 5. We used the slit width and the number of the visible spectrum, d over lambda, and that gives us approximately 3 for visible spectrum of 400. And we also got approximately 6 for a visible spectrum of 700. So the order becomes m equals to 3. So hope you enjoyed the problem. Feel free to send any questions or comments, and have a wonderful day.